All right, we're in the final section for the course. We're just going to kind of put together some basic sine functions so you can look at how we can model them on a calculator just in general. First of all, we're going to be in degree mode, so make sure you hit the mode button on your calculator and make sure this right here is highlighted on degree. So don't have it like this. Go over to degree, click on it, make sure it's highlighted on degree, otherwise the answers won't really make sense. So here's what we're going to be doing. Here's an example of the model of the sine function, which is right here. And what we have is this right here is going to be our amplitude. And this right here is going to be our midline. So if we want to use our calculator to tell us what is the height at an angle 0, you're just going to plug in 100 plus 100 sine 0. Now before you hit enter, you should agree that this should be, at a sine of 0 degrees, should be 100 feet up in the air. There it is, 100 feet up in the air. So this is 100. Use your calculator to find out how off the ground when it moves 45 degrees. So now if you're thinking about it, so here's the Ferris wheel, and we're not down here, we're actually down here at 0 degrees, so we move 45 degrees, we should be up pretty high off the ground when we're up here. So if we do the same thing we did up here, and we put in 45 degrees, now we're 170 feet off the ground. Now, at 90 degrees, right here, where should we be? So we're at 90 degrees. We should be, if we did this correctly, at 200 feet. And why that would make sense, all right, there's your 200 feet, is because at 90 degrees, we're all the way, if we think up here, here's 0 degrees where we start, at 90 degrees, we're all the way up here, we're all the way at the top. So we label this Ferris wheel, what we're really doing, we're looking at this is our 100 feet, this is 200, so this is our midline right here, and our amplitude is 100 feet here, from here to here. So let's take a look at the next problem. Let's say we have a Ferris wheel that's 100 feet tall. What would the equation be? Hopefully, you'd see that it's this side of our angle. Now, where are we at an angle of 45 degrees? Again, go here, 50 plus 50 sine 45, and we're at about 85 feet. At 90 degrees, you don't even need a calculator because, again, at 90 degrees, when we're referring to this Ferris wheel, this is 0 degrees here. We're going up to here, 90 degrees, we should be 100 feet up in the air. We should be at our highest point. When we're at 270 degrees, so we're 90, 80, 270, now we're down here, we should be at our lowest point, which is 0. If you want to check on here, we can always check. So if we're at 270, we should get an answer of 0, which we do. So let's say we have a function here, which at 0 starts at 25, goes to 50, 25, 0, 25. What we notice is that we have a midline that's equal to 25. We have an amplitude that's equal to 25. What does it look like? Something like this. If we wanted to write the equation, it would be 25 plus 25 sine of A. And again, that's based off the middle of this graph is 25, and from the midline to the height, it's another 25. And then you could use this to answer any question you want based on the graph. So hopefully you have a better understanding of how sine works. Good luck.